episode of Teves Development. Today we're going to be going over another practice problem. This is a commonly asked interview question, again amongst entry-level programmers, so let's jump into it. So here's our problem statement. Given an array of integer nums containing n plus 1 integers, where each integer is in the range 1 to n inclusive, there is only one duplicate number in nums, return this duplicate number. Okay? And we are given an example. Our input would be nums 1, 2, 3, 4, 10, 5, 6, 7, 8, 9, 10. And our output would be 10 because that is the duplicate number. So I've done a little bit of work just before this video. I've set up nums as the input we're going to take, and I'm going to print out whatever we get from our method, which we are doing here, this find duplicate method. Again, this is taking in an int array of numbers, which it looks like we are going to be given an array of integers. And let's get started. So there's a couple of ways about thinking about this problem. The first one would be to check each number against each other, right? We could check 1 against 2, 1 against 3, 1 against 4, 1 against 10, so on, so forth, until we do 2 against 3, 2 against 4, and so on, so forth again. This is a very inefficient way that we could solve this problem, but it would work. The next way we can do this is using internal Java tools, such as a set. So that's what we're going to use today. Let's start by adding in a set of an integer. We'll call this scene, and this will be a new hash set. And this will take in a integer again. Now we have to import the set code into our program. And now we have a set. What a set does is we can insert integers into this set and we will guarantee to have no duplicates. On the flip side of this, we don't know the order of the set. We just know that no duplicates will be added to this set. So the next thing we can do is we have to go through all of these numbers. The best way to do that would be using a for loop. We could do for in num inside of numbers. And now we will loop through numbers with num. So in this case, num would be 1 on the first iteration, the second iteration it would be 2, the next one it would be 3, so on and so forth. Now what we can do is we can use this scene variable to see if we have seen the number that we're looking over before. The idea behind this is that if we've seen it, then we know it is a duplicate. And we know that we can't have any duplicates inside of our set, so we'll have to figure out a way around that. So why don't we do something along the lines of if scene contains num, and we know that that's the duplicate, so we can return num. But if this is not true, then we should add that number to our set. So we could say scene.add, and then we can add that number. So let's think through this for a second. For our example of 1 through 10, with a duplicate inside there somewhere, we would go to 1, we would check if it's inside our scene set, which would be no. Then we'd go to 2, check, add it, 3, check, add it, 4, check, add it, 10, check, add it, and then so on and so forth until we get to 10 again. Now, once we do this scene.contains num, we actually will know that 10 is already inside of our set to where we know that 10 is our duplicate number. One thing we can assume with the program is that there is only one duplicate number in nums. Otherwise, this solution wouldn't necessarily work. But because we can assume that there's only one duplicate, this does. Now we're missing one thing. We still need to return something here because we may never get inside this if statement, right? What if there's no duplicates inside of this? Well, A common programming practice here is we can return -1 for this integer. We are assuming that it is in a positive range, 1 to n. So by returning a negative number, or like 0, but 0 is a common success exit code, if we return -1, then we'll know that this find duplicate did not have any duplicates. So why don't we give this a run real quick and see if it works. We should receive 10 here, which we do. What if we changed this to 11 and then added a 13 here, and we have no duplicates, right? We should see -1 this time, which we do because we have no duplicates. But let's say we add in a 9 here. On this run, we will get 9. Great. So from a quick testing, we know that our program is working. We can do more tests to see if there is any edge cases we're missing, but it looks like this is pretty good to start. There are multiple ways to solve this, as you can imagine. Another way would be to actually sort this list and then compare each previous number to the next one. So if we sorted this list, for example, it would be something along the lines of this. We would move the 9 to here, and then we would move the 11 to here, and then we could check 1 against 2, 2 against 3, 3 against 4, 4 against 5, 5 against 6, 6 against 7, 7 against 8, 8 against 9, 9 against 9. We know that 9 is our duplicate. Again, this solution works if you sort it because we can assume that there is only one duplicate inside this array. So you can loop over all of these like in an n-squared way, like we talked about at the beginning, checking 1 against all of these and then 9 against all these, so on and so forth. That's not very efficient. The two ways that I just explained, either the sorting way or using a set, are two of the more efficient ways, and interviewers would like you to use these solutions. If you have any questions, leave a comment down below. Let me know which one you like better, method 1 using the set or method 2 using the sort. As always, like the video and subscribe if you find these videos very helpful. Thanks for watching. We'll see you next time.